quest to keep our food safe birthed a chemical miracle that quietly began erasing the very shield protecting life on Earth. Imagine a family sleeping soundly in the dead of night, their home quiet and still. Downstairs in the kitchen, a gleaming new refrigerator hums a steady, comforting tune. They believe this modern marvel is a guardian, keeping their milk cold and their meals fresh. But hidden inside its metal veins, a silent, invisible threat is already at work. There is no smoke, no foul odor, and no warning siren to wake them. This machine, bought to protect the family from spoiled food and sickness, is harboring a synthetic ghost. As the compressor works, tiny fractions of this miracle gas slip through microscopic cracks. It drifts up from the kitchen floor, passing right through the ceiling, moving silently past the sleeping children. That phantom gas from the kitchen was just the vanguard of a massive, unseen invasion. Every time an early refrigerator hummed to life, or a newly invented spray can hissed in a bathroom, a tiny amount of this invisible gas escaped into the world. It was engineered to be completely unreactive, meaning it had no smell, it could not catch fire, and it did not poison the air we breathe. To the people using it, the gas simply vanished without a trace. But in reality, nothing just vanishes. Because these chemicals were so perfectly stable, they did not break down when they hit the air. Instead, they gathered in the atmosphere, molecule by molecule, ton by ton. Every squirt of hairspray, every blast of spray paint, and every discarded icebox added to an invisible ocean of gas pooling above our cities. Humanity was pumping thousands of tons of synthetic chemicals into the air, completely blind to where they were going. It is a chilling human mystery how easily we place our blind trust in things we cannot see. We eagerly brought these chemical marvels into our most intimate spaces, spraying them on our bodies and storing our food inside them without ever asking what happened after the hissing stopped. We assumed that because it did not hurt us right away, it was perfectly safe. Think about the profound unease of that reality. Millions of people, across decades, were happily spraying their homes with a substance that was secretly setting a global trap. We were so captivated by the convenience, so relieved by the modern comfort, that we never bothered to look up. We traded the safety of our entire world for a colder glass of water and a better can of bug spray. While humanity went about its daily business below, a silent destruction was unfolding in the vast, empty sky above. The invisible gas that had drifted out of millions of kitchens did not stay near the ground. It slowly floated higher and higher, leaving the clouds behind, entering a realm where no human could survive. Up there, in the freezing dark, a terrifying unraveling began. An invisible shield, one that had guarded the earth since the dawn of time, was being slowly and methodically eaten away. There were no explosions, no falling debris, just a quiet chemical erasure happening miles above our heads. While we slept, worked, and played, the sky was being stripped of its armor, leaving us completely exposed to a deadly force from space. The quiet dismantling of our sky went unnoticed for decades, hiding a global catastrophe in plain sight. High above the clouds sits a fragile, invisible layer of gas called ozone. Think of it as the Earth's very own sunscreen. This incredibly thin layer is the only thing standing between every living creature on the planet and the deadly burning radiation pouring out of the sun. Without it, the sun's raw power would scorch the surface, blinding animals, destroying crops, and making it impossible to step outside. The ozone layer is not a thick wall of steel or concrete. It is just a delicate mist of molecules, constantly breaking apart and reforming in a delicate cosmic dance. It is so fragile that if you took all the ozone in the sky and brought it down to Earth, it would only be as thick as 2 pennies stacked together. Yet this fragile mist is the absolute foundation of our survival. This brings us to a deeply unsettling truth. The very chemicals we invented to make our homes safe and comfortable were the exact weapons destroying our only shield. The gases we trusted to cool our food and propel our medicines were acting like invisible missiles, floating up into the stratosphere to tear apart the ozone. It is a dark irony that borders on the tragic. In our desperate attempt to protect our own families from harm, we had accidentally engineered a doomsday device for the entire planet. We had weaponized our own appliances against the very sky that kept us alive. Every time a family felt the cool relief of a modern air conditioner, they were unknowingly pulling the trigger on a global disaster. To understand how we accidentally turned our home appliances into atmospheric weapons, we must look at the nightmare we were trying to escape. Transport yourself back to the early 1920s, a time when keeping food cold was a matter of life and death. Before our modern miracle gases existed, the first electric refrigerators were truly terrifying machines. To make the air cold, these early ice boxes had to use harsh, highly toxic chemicals. They were filled with deadly poisons that had the power to kill a person in minutes. A small leak in the middle of the night was not just an inconvenience, it was a death sentence. Entire families would go to sleep, completely unaware that a corroded pipe in their kitchen was slowly filling their home with a lethal, suffocating cloud. Newspapers from the era are filled with grim stories of people who simply never woke up, murdered by the very machines they bought to keep their food safe. The deep, paralyzing fear of a toxic gas leak in the kitchen drove scientists to search desperately for a harmless alternative. To understand the terror of the early 20th century kitchen, you have to look inside the crude machines of the time. The first mechanical refrigerators introduced in the 1920s were massive, clunky beasts weighing hundreds of pounds, and they relied on harsh, foul-smelling chemicals to pull heat out of the air. Manufacturers used highly reactive industrial gases like ammonia, methyl chloride, and sulfur dioxide simply to keep perishable food cold. These highly toxic and corrosive substances were never meant to be kept inside a family home. The harsh chemicals would slowly eat away at the copper pipes, brass fittings, and rubber seals of the refrigerator compressor. It was often only a matter of time before the weakened lines ruptured under pressure, pumping invisible, suffocating poison directly into the living room and adjacent bedrooms while the family slept. Imagine lying awake at night, terrified of your own expensive kitchen appliances. For thousands of families in the late 1920s, the electric refrigerator was not a symbol of modern convenience, but a ticking time bomb sitting quietly in the dark corner of the house. The very machine they purchased for hundreds of dollars to keep their children safe from spoiled food and bacterial infections could turn into a silent killer without a single warning sign. Local newspaper headlines frequently carried grim stories of entire families found lifeless in their beds, victims of a sudden sulfur dioxide or methyl chloride leak during the night. The kitchen had become a place of profound anxiety, shadowed by the constant lingering dread that a simple mechanical failure could erase a family overnight. In a single incident in Chicago, more than 24 people were poisoned when a centralized refrigeration system vented toxic gas into their apartment building. This gripping fear of the household icebox forced the rapidly growing refrigeration industry to a grinding halt. Major manufacturers watched their sales plummet as public trust evaporated, demanding an immediate scientific solution before the modern dream of the electric refrigerator died completely. The financial stakes were massive, with millions of dollars in potential revenue hanging on the creation of a fundamentally safe cooling technology. A frantic race began among the world's top corporate scientists to find a chemical miracle that would not kill people. The engineering rules for this new invention were incredibly strict, leaving absolutely zero room for error. The new gas required a specific boiling point to absorb heat, but it could not catch fire, it could not explode under compression, and it absolutely could not poison a family if the containment system leaked. It was a desperate hunt for a ghost, a perfect chemical compound that simply did not exist anywhere in nature. Industrial researchers mixed and tested countless hazardous fluids in their laboratories, searching for something that was entirely inert, non-corrosive, and harmless to human biology. The corporate pressure mounted daily as the tragic death toll from toxic leaks continued to rise across the country, threatening to bankrupt the appliance industry. The heavy burden of solving this deadly problem fell onto the shoulders of a brilliant but tragic mechanical engineer named Thomas Midgley Jr. Working under the umbrella of General Motors, he was a man driven by immense pressure, tasked by desperate corporate executives to engineer a completely safe alternative before more lives were lost. Midgley retreated into his Dayton, Ohio laboratory, determined to force the laws of chemistry to bend to his will. He understood the grim financial and human stakes better than anyone, knowing that every single day without a solution meant another family was at severe risk of asphyxiation. The crushing weight of those accidental deaths pushed him to stare closely at the periodic table, driving him to experiment with highly volatile combinations of elements that other mainstream scientists had completely ignored due to their known toxicity. Driven by this relentless pressure to save lives and rescue a failing industry, Midgley and his small team of researchers worked exhaustively through the periodic table. In 1928, after just 3 days of intense focus, he finally stumbled upon a unique combination of synthetic atoms that would alter the Earth's atmosphere and change the world forever. In a fateful moment of scientific discovery, Midgley deliberately mixed carbon, chlorine, and fluorine together to synthesize the very first chlorofluorocarbons, universally known as CFCs. In the simplest chemical terms, he had built a microscopic fortress. The newly forged molecules were unusually heavy, incredibly stable under extreme pressure, and seemed absolutely perfect for the dangerous job of domestic refrigeration. This synthetic gas ignored intense heat. It easily withstood highly corrosive acids, and most importantly, it did not react with the human respiratory system at all. It was a masterpiece of modern chemical engineering, an odorless and non-flammable substance so unnatural and unshakable that it appeared to be the ultimate safe harbor the terrified public had been praying for. To prove to a terrified public and a skeptical scientific community that his invention was truly harmless, Midgley staged a chilling and highly theatrical demonstration. In 1930, standing before a large crowd of reporters at a meeting of the American Chemical Society, he took a deep, deliberate breath of the raw CFC gas directly into his own lungs. He then turned and slowly blew the concentrated gas out over a lit candle, instantly extinguishing the flame without a single spark. This famous stunt simultaneously proved the gas was entirely non-toxic and completely non-flammable. The crowd erupted in applause, completely unaware of the profound, global danger that had just been unleashed into the room. That single dramatic breath of synthetic gas thoroughly convinced the industrialized world that the dark age of toxic refrigerators was finally over. The spectacular demonstration instantly erased decades of consumer anxiety and regulatory hurdles, immediately clearing the path for absolute market dominance and securing billions of dollars in future manufacturing contracts for the appliance industry. Massive corporations immediately saw the ultimate financial prize in Midgley's unbreakable molecule. General Motors quickly partnered with the chemical giant DuPont to form a new joint venture called Kinetic Chemicals, specifically designed to mass-produce this revolutionary new substance. They packaged the invisible miracle gas under the friendly, catchy, and highly marketable trade name Freon. Almost overnight, massive industrial factories began churning out hundreds of thousands of tons of Freon to meet explosive consumer demand. The terrifying ammonia and sulfur dioxide machines were rapidly thrown onto the scrap heap. They were replaced by sleek, quietly humming refrigerators and brand new home air conditioning units that promised absolute safety for every family in America. As Freon flooded into millions of homes, automobiles, and businesses across the globe, humanity celebrated its clever technological triumph. The world eagerly embraced this chemical miracle, completely blind to the fact that these indestructible molecules were slowly drifting upward, creating a silent and devastating catastrophe gathering high above their heads in the Earth's stratosphere. Families across the country breathed a collective sigh of immense relief as the 1930s progressed through the Great Depression. The dark days of waking up to the sharp metallic smell of poison in the kitchen were finally over. Lethal refrigerants like sulfur dioxide and methyl formate, which had claimed lives in crowded hospitals and dense apartment buildings, were rapidly being phased out of domestic life. Parents could now bring home a shiny, humming Frigidaire unit without the secret, gnawing fear that a toxic chemical leak in the middle of the night might steal their children away in their sleep. But this profound peace of mind was a tragic illusion, because in their desperate rush to escape an immediate, deadly threat, they had unknowingly traded a swift household killer for a slow, invisible, and truly global disaster. This new miracle gas did not just stay trapped inside domestic kitchen appliances. It sparked a massive explosion in what logistics experts know as the cold chain, allowing highly perishable fresh food to travel thousands of miles across burning deserts and wide oceans without spoiling. Refrigerated railway cars and massive cargo ships suddenly had the reliable cooling power needed to transport California produce to New York markets in pristine condition. Soon, the cooling power of Freon spilled out into every corner of daily life as the post-war economic boom took hold. It pumped freezing air into packed movie theaters during the sweltering summer months. It chilled the insides of family cars on long cross-country road trips, and it cooled down massive, roaring industrial machines on crowded factory floors that previously had to shut down during the hottest days of August. As the world quickly grew accustomed to this manufactured chill, the boundaries of where humans could comfortably live and work expanded forever. Sweltering regions that were once considered too hostile for large populations suddenly transformed into booming real estate markets. Entire American cities across the Sunbelt, from the humid coasts of Miami to the arid deserts of Phoenix, saw massive population spikes made possible entirely by synthetic cooling technology. Looking back at that era reveals a chilling sense of human arrogance fueled by mid-century industrial triumphs. Chemical companies proudly marketed their synthetic creations under the banner of better living through chemistry, and society eagerly bought into the promise. We truly believed we had finally conquered the harsh, unforgiving forces of nature, successfully bending the temperature of the indoor air itself to our absolute and unquestioned will. There was a dangerous, unspoken confidence that we had created a perfect, consequence-free machine that operated entirely outside the laws of ecological balance. It leaves a lingering, heavy unease when we realize just how easily we assumed we were smarter than the natural world, completely blind to the dark atmospheric forces we were quietly unleashing. Engineers tested these compounds for flammability and toxicity, but nobody bothered to test what would happen to the sky. The corporate creators of this miracle gas soon found entirely new and highly profitable ways to exploit it. They discovered that the exact same chlorofluorocarbon chemicals keeping refrigerators cold were also perfect for pushing liquids out of tiny nozzles at high velocity. Because the gas liquefied under moderate pressure and vaporized instantly at room temperature, it became the ultimate propellant for a rapidly expanding consumer goods industry. Almost overnight, these synthetic chemicals were packed into hundreds of millions of pressurized aerosol cans to blast out hairspray, bug spray, shaving cream, and fresh household paint. The applications seemed virtually endless, as industrial chemists even blew the gas into liquid plastics to create the soft, bouncy polyurethane foams used in living room cushions, comfortable mattresses, and the heavily padded dashboards of modern automobiles. With every press of a plastic button and every newly stuffed living room chair, the invisible gas seeped further into the fabric of modern life. Consumers were discharging thousands of tons of chlorofluorocarbons directly into their bathrooms, kitchens, and garages every single day. The chemical signature of this industrial revolution was quietly weaving itself into the very air we breathed, leaving a permanent trace of our daily conveniences. The 1950s and 1960s brought an innocent, booming culture of eager consumers who embraced these modern marvels with open arms and open wallets. Driven by aggressive advertising campaigns that promised effortless living, it was a bright, happy, and incredibly busy world, filled with the constant cheerful hissing of disposable spray cans and the steady rhythmic humming of millions of newly installed cooling machines. Yet, beneath the colorful surface of this mid-century golden age, a profound sense of dread begins to take shape for anyone looking back at the data. While families enthusiastically celebrated their new household conveniences and perfectly climate-controlled supermarkets, an invisible, silent poison was steadily building up in the air all around them, accumulating in the lower atmosphere entirely unnoticed by the scientists who had created it. It is deeply unsettling to realize the heavy atmospheric weight carried by such simple, everyday actions. Every single time a grandmother stood in front of her bathroom mirror and sprayed her hair into place for church, she was unknowingly feeding a growing monster. A brief 3-second burst from an aerosol can release billions of synthetic molecules that would long outlive the person who pressed the nozzle. When a father proudly fixed a Freon leak in his family car air conditioning system, venting the old gas directly into his suburban driveway, he had no idea he was contributing to a slow-moving global disaster. They were just ordinary people living their daily lives, completely unaware of the dark chain of chemical events they were setting into motion with every single trip to the local hardware store. These seemingly harmless daily routines quietly released an endless stream of invisible chemicals up into the open sky. By the early 1970s, the global production of chlorofluorocarbons had skyrocketed to nearly 1 million metric tons per year, and almost all of that staggering volume was intentionally designed to be sprayed, vented, or leaked directly into the surrounding environment without a second thought. The exact scientific reason these chemicals were so deeply loved by manufacturers was a simple but powerful chemical trait known as stability. The carbon and fluorine bonds were incredibly strong. In basic terms, being stable just meant that the synthetic gas refused to react, break down, or mix with absolutely anything else it touched, making it incredibly predictable and easy to manufacture on a massive industrial scale. It did not cause copper metal pipes to rust. It absolutely would not catch fire even if exposed to a direct electrical spark, and it did not break down or cause biological harm when inhaled by a living person. Unlike highly flammable propane or highly corrosive ammonia, this incredible chemical stubbornness made chlorofluorocarbons seem like the safest, most perfect industrial invention in all of human history. But that exact same stability hid a horrifying, long-term truth that no one in the scientific community was actively looking for. Because the gas never reacted with anything on the ground, it never broke down in the lower atmosphere, meaning almost every single ounce of the chemical ever sprayed was still out there. It was simply accumulating in the air, slowly drifting upward toward the edge of space, waiting to be unlocked. The very trait that made these chemicals a miracle of modern engineering also made them an immortal threat. Because the tightly bound carbon, chlorine, and fluorine atoms never reacted with anything in the lower atmosphere, the gas never broke down, and it never went away. Every single ounce of the chemical ever sprayed from an aerosol can or leaked from a discarded refrigerator was still out there, accumulating in the dark, unmonitored shadows of our atmosphere. This unbreakable chemical armor meant that humanity was unknowingly building a permanent, invisible reservoir of destruction right above our heads. While chemical corporations celebrated record profits and consumers marveled at the convenience of instant refrigeration, a silent stockpile of synthetic vapor was steadily massing in the sky, completely immune to the natural biological cycles that break down ordinary pollutants. Once released from a pressurized hairspray nozzle or a fractured cooling pipe in a residential air conditioner, the gas began a slow, silent journey upward. It did not wash away in the seasonal rain, and it did not settle into the soil. Instead, the invisible molecules drifted higher and higher, slipping effortlessly past the heavy storm clouds and the turbulent weather systems that routinely cleansed the lower air. It was a relentless, upward crawl that took years, sometimes decades, for a single molecule to complete. Traversing the 10 to 30 miles from the surface of the Earth to the stratosphere, this migration was the slow, unstoppable march of an invisible army, heading toward a destination no government agency or private corporation had ever bothered to monitor. For nearly 50 years, from the initial invention in the late 1920s through the booming consumer decades of the mid-20th century, this invisible army gathered in the high sky, multiplying with every passing day. Millions of metric tons of this synthetic gas pooled in the freezing, thin air at the very edge of space, waiting in total silence as the global inventory continued to swell. The sheer scale of this unseen accumulation is terrifying to comprehend. While suburban families enjoyed the modern comforts of General Electric refrigerators and the daily convenience of aerosol deodorants, a massive, unbroken blanket of chemical vapor was quietly wrapping itself around the entire planet, completely undetected by the very people who had manufactured it. The sky above remained perfectly blue and seemingly untouched, hiding the colossal weight of decades of industrial exhaust. Below that pristine illusion, thousands of factories across North America and Europe were pumping out millions of pounds of chlorofluorocarbons annually, completely unaware that their miracle product was fundamentally altering the chemical composition of the upper atmosphere. The illusion of absolute safety finally began to crack in the early 1970s, when a new generation of highly sensitive scientific tools was invented. British scientist James Lovelock developed an instrument called the electron capture detector, and for the first time, researchers had the technology to look closely at the invisible composition of the air itself, measuring tiny, almost imperceptible traces of synthetic chemicals floating in the wind at parts per trillion. The initial data they gathered during a 1971 research voyage to Antarctica was confusing and then deeply unsettling. No matter where they took their air samples, from the smoggy, congested streets of London to the pristine, freezing isolation of the southern ice cap, the results were exactly the same. The CFCs, invented in the 1920s, were literally everywhere, saturating every remote corner of the global atmosphere. This unsettling discovery forces a chilling question about our collective industrial blindness. How could humanity pump millions of tons of a synthetic gas into the air for half a century, building a multi-billion-dollar global industry without a single person checking to see where that invisible chemical waste was actually going? It exposes a dark, enduring flaw in human nature, the dangerous assumption that if something is out of sight, it is permanently out of mind. We trusted the vastness of the sky to swallow our industrial mistakes, never imagining that the boundless heavens could actually fill up with the invisible, indestructible waste of our daily conveniences. The world had simply looked away, leaving a catastrophic scientific blind spot that two men were about to uncover in the autumn of 1973. While the chemical industry continued to expand its global reach, these two researchers prepared to ask the exact question that everyone else had ignored. The detectives who finally cracked this atmospheric cold case were not action heroes or seasoned criminal investigators, but a pair of chemists named F. Sherwood Rowland and Mario Molina. They were quiet, deeply curious men sitting in a university laboratory in Irvine, California, staring at a complex atmospheric puzzle that the rest of the world did not even know existed. Roland and Molina simply wanted to know what actually happens to a chemical that never breaks down in the lower atmosphere. Armed with a modest research grant, they decided to trace the complete life cycle of these molecules, launching a rigorous academic investigation into a mystery that no government regulator or chemical corporation had ever cared to fund or explore. Their investigation began with lonely, quiet work, far removed from the bustling industrial factories producing the chemicals. They stood in front of massive chalkboards in their California office, scratching out complex chemical kinetics and simple math equations to balance a global ledger of invisible gas, tracking its slow migration upward. They meticulously calculated the total historical amount of the chemical that had been manufactured since its invention, using industry production records, and compared it to the exact atmospheric concentrations Lovelock had recently measured. The numbers matched perfectly, proving beyond a shadow of a doubt that not a single molecule of the gas had been destroyed by any natural process. In the quiet hum of their laboratory, the chalk dust settled on an undeniable and terrifying truth. The entire chemical inventory of the 20th century, every single canister of Freon ever produced since 1928, was still intact and floating directly above them in the sky. Using a rigorous, step-by-step logical process, Roland and Molina began to rule out every possible earthly destination for the gas. They proved the molecules were not being absorbed by the oceans, they were not sinking into the dirt, and they were not being washed out by the rain. Their math pointed them straight up, confirming that the gas had nowhere else to go but the very roof of the world, where the harsh radiation of the sun finally awaited. The researchers systematically crossed out every natural resting place on the planet. Exhaustive environmental sampling proved the gas was not dissolving into the oceans, it was not being absorbed by the dirt, and it was not washing out in the rain. Every calculation pointed in one impossible direction. The unbreakable synthetic chemicals had bypassed all earthly sinks and had nowhere to go but straight up into the atmosphere. The chilling realization struck the chemists not as a sudden flash, but as a slow, creeping dread inside their laboratory at the University of California, Irvine. Sherwood Rowland and Mario Molina stared at the atmospheric modeling numbers that proved the gas was drifting 10 to 30 miles above the clouds. The completely inert compounds were pooling directly in the stratosphere. This was the exact altitude where the delicate ozone layer lived and operated. The very shield that protected all biological life on Earth from burning up under lethal solar radiation was now sharing its space with millions of tons of man-made chemicals. The safety of the entire planet had been fundamentally compromised by the exhaust from everyday hairspray cans and kitchen refrigerators. The invisible migration of these chemicals took years to complete, slowly drifting upward through the lower atmosphere without interacting with a single other element. This delayed journey had silently turned the upper sky into a ticking time bomb, accumulating a massive reservoir of synthetic gases that humanity continued to pump out at a rate of nearly 1 million tons per year. High above the protective cloud cover, a deadly trigger was waiting in the freezing vacuum. Down on the ground, the chlorofluorocarbon gases were perfectly stable and utterly harmless, but up in the stratosphere, they faced the raw, unfiltered power of the sun. Intense, high-energy ultraviolet light from the solar system slammed directly into the floating chemical compounds. This brutal solar radiation finally did what absolutely nothing on the surface of the Earth could achieve. The specific wavelength of ultraviolet light smashed the supposedly unbreakable carbon-chlorine bonds apart in a violent, invisible collision. The miracle gas that had revolutionized modern industry was shattered instantly upon entering this harsh upper domain. From the microscopic wreckage of that shattered molecule, a chemical killer was born. The process of photodissociation fractured the compound, and the broken gas released a single, highly reactive atom of chlorine directly into the fragile atmospheric layer. This lone element was suddenly free to roam the very region where it could inflict maximum devastation. This isolated element was not a harmless byproduct of solar radiation. This freed chlorine atom was highly aggressive, chemically unstable, and incredibly hungry for electrons. It was a tiny, invisible monster waking up in the exact atmospheric layer where it could find its preferred prey, ready to dismantle the molecular structures that kept the planet habitable. The protective canopy of the world, composed of 3 oxygen atoms bound together into ozone, was now trapped in a high-altitude cage with a microscopic predator. The chlorine atom was perfectly designed to hunt down these specific oxygen clusters, initiating a chain reaction that would unravel the atmospheric defense grid at a terrifying speed. The resulting kill count of this chemical monster was almost too massive for the scientific community to comprehend. A single piece of chlorine did not just break one piece of the ozone shield and disappear. It acted as a catalytic machine, tearing apart a molecule of ozone, stealing an oxygen atom, and then dropping it to immediately move on to the next target. The sheer horror of the chemical math revealed that one lone chlorine atom could survive in the stratosphere for decades, devouring up to 100,000 pieces of protective ozone before it finally washed out of the sky. The planetary shield was not just being damaged by a static pollutant, it was being systematically eaten alive by an endlessly repeating loop of destruction. Look up at the sky right now and imagine the sheer scale of the invisible slaughter happening miles above the clouds. Every time someone pushed an aerosol spray button, cleaned a circuit board, or cooled a living room, they were unknowingly sending millions of these hungry chemical monsters upward to join the atmospheric massacre. There was no sound to warn the population below, and no dark storm clouds to signal the impending danger. The sky was bleeding out in complete silence, ripped apart atom by atom across the entire globe, while the world went about its day entirely oblivious to the catastrophic thinning of its only defense against the sun. The quiet destruction happening above our heads meant that the severe sunburns, rampant skin cancers, and blinding cataracts of the future were already being locked into place. As the ozone layer thinned, the biological toll on humanity, agriculture, and marine ecosystems was silently compounding with every passing hour that the chemicals remained in production. Rowland and Molina knew they could not keep this apocalyptic secret confined to their university laboratory. In June 1974, they took a brave and desperate step, publishing their terrifying findings in the prestigious journal Nature for the entire scientific world to see, risking their professional reputations to expose the impending disaster. They were essentially screaming that the sky was falling, presenting data that challenged a multi-billion-dollar global industry. Their published warning was simple and brutal. If humanity did not immediately stop manufacturing and spraying this miracle gas, the Earth's protective shield would vanish, and lethal ultraviolet radiation would mercilessly scorch the surface of the planet. But the initial reaction to their terrifying truth was an agonizing wall of silence and fierce corporate denial. Chemical manufacturers immediately launched campaigns to discredit the research, calling the findings absolute nonsense. Imagine the deep, crushing frustration of knowing the world is accelerating toward an ecological cliff, and absolutely no one is hitting the brakes. Two men possessed the mathematical proof that the planet was in mortal danger, yet the rest of civilization was too busy styling their hair with aerosol sprays, cooling their newly purchased cars, and blindly enjoying the cheap comforts of modern life to listen to the scientific prophets of their own atmospheric doom. The crushing weight of Sherwood Rowland and Mario Molina's ignored 1974 warning hung in the air, a silent countdown ticking while the world looked the other way. Their peer-reviewed paper in the journal Nature had clearly outlined the mechanism of chlorine destroying stratospheric ozone, yet the political response throughout the late 1970s remained paralyzingly slow. Instead of concern, the chemical industry launched a relentless and calculated counterattack. Massive corporations like DuPont had built an $8 billion empire on the back of these miracle gases, supporting over 200,000 jobs. They were desperate to protect their lucrative patents and vast manufacturing infrastructure at any cost. They unleashed their immense financial power and political influence to wage an absolute war against the two scientists who dared to expose the truth. Forming lobbying groups like the Alliance for Responsible CFC Policy, chemical manufacturers weaponized every resource at their disposal to cast doubt on the terrifying reality of a dying sky. The smear campaign was swift and brutal, transforming respected researchers into public targets. Industry spokespeople flooded the press and congressional hearings, publicly mocking the scientists. They dismissed the detailed photochemical models as science fiction, calling the dire warnings utter nonsense designed only to secure government grants and scare the uninformed public. Cut off from institutional funding and shunned by many of their academic peers, the scientists faced a profound and chilling isolation. Rowland found his speaking invitations abruptly canceled, leaving them to stand alone in the dark. They held the horrifying theoretical proof of a global catastrophe, while the very people poisoning the atmosphere called them crazy. This vicious campaign of denial successfully bought the industry time, allowing millions more tons of the destructive gas to bleed into the atmosphere. For a full decade after the initial warning, factories continued churning out chlorofluorocarbons, pumping an estimated 10 million additional metric tons of the synthetic chemicals directly into the vulnerable sky. To maintain their grip on the market, the chemical giants set a brilliant and impossible trap. Testifying before Congress, lobbyists loudly demanded hard, physical proof that the invisible shield above the Earth was actually breaking apart. They insisted that abstract computer models were insufficient, refusing to stop production without direct atmospheric measurements showing actual depletion. It was a deeply cynical strategy, built on a terrifying scientific reality that the corporations fully understood. They knew perfectly well that chlorofluorocarbons take decades to migrate upward. By the time humanity could physically see the ozone layer disappearing, 50 years of chemical destruction would be locked in, and it would be far too late to save the planet. This standoff revealed a dark and unsettling truth about human nature, a fatal flaw that surfaces whenever massive corporate profit clashes with long-term survival. The demand for absolute scientific certainty became a weaponized shield against regulation. We possess a chilling tendency to wait until the house is completely engulfed in flames before we finally decide to go out and buy a hose. It remains a haunting mystery how easily society accepted this deadly wager. By the dawn of the 1980s, global production exceeded 1 million tons annually. We were willingly gambling the future health of our children and the very survival of life on Earth, all for the fleeting convenience of a colder Freon refrigerator and a cheaper can of aerosol hairspray. While the world blindly accepted this terrifying gamble, the true answer was quietly forming in the most desolate place on the planet. The atmosphere over Antarctica was about to reveal the consequences of our inaction, driven by unique polar vortex winds and stratospheric ice clouds that created the perfect chemical reactor for rapid ozone destruction. By the early 1980s, the narrative shifted drastically to the frozen, untouched expanse at the very bottom of the world. Here, a small, unassuming team from the British Antarctic Survey was stationed at Halley Bay in the relentless cold of the South Pole, operating on a shoestring budget far removed from the high-stakes political battles in Washington. They were not looking for a global catastrophe, but simply performing routine, incredibly boring daily checks on the atmosphere. To measure the sky, they relied on a 1920s-era Dobson ozone spectrophotometer. They were completely unaware that this basic, manually operated instrument was about to uncover the greatest environmental crime in human history. Life for these researchers was defined by harsh extremes and unbroken stretches of white ice. Every single day they stepped out into the freezing, howling wind, their faces stinging against temperatures dropping below -40 degrees Celsius. They endured the brutal elements just to maintain a continuous meteorological record that had been kept since 1957. They were totally cut off from the rest of civilization, living a life of quiet repetition in a frozen wasteland. It was in this profound isolation, surrounded only by endless snow and biting cold, that their mundane daily chores suddenly turned into a nightmare when the data logs from October 1982 began showing severe anomalies. Standing alone in that frozen desolation, the isolated researchers stared at their instruments in absolute disbelief. Joseph Farman and his team observed the spectrophotometer recording a staggering 30% drop in stratospheric ozone levels, a sudden and violent deviation from the steady historical averages they had documented over the previous 2 decades. The data coming out of their simple equipment made absolutely no sense. The old dials and meters were suddenly spitting out numbers that defied all known meteorological science. The readings were so extreme that researcher Jonathan Shanklin initially assumed the aging machines themselves were broken, or that dust from distant volcanic eruptions was skewing the ultraviolet light. But as they checked and rechecked their equipment, even ordering a brand new replacement machine from England, a chilling reality began to set in. The impossible readings were accurate, and they were screaming a terrifying truth. Massive, continent-sized chunks of the Earth's protective ozone shield were simply gone, ripped open exactly as Rowland and Molina had predicted. The researchers at the British Antarctic Survey stared at the numbers in disbelief, completely convinced their equipment was failing. Operating out of the isolated Halley Bay station in the early 1980s, the team actually threw out their earliest readings. They blamed the extreme Antarctic cold for breaking their old, simple Dobson spectrophotometers, assuming the steep drop in ozone was a mechanical glitch rather than a planetary crisis. But as they brought in brand new instruments and painstakingly checked the calibration data again and again, a blood-freezing reality washed over the isolated team. The replacement machines were not broken, and the impossible numbers flashing before them were entirely real. A staggering 40% of the ozone layer over the continent had simply vanished during the Antarctic spring. The silent, freezing sky above them was hiding a terrifying secret that the world was utterly unprepared to face. Because ozone is an invisible gas, the atmosphere looked exactly the same to the naked eye. Yet high in the stratosphere, a catastrophic chemical reaction was silently unfolding. The researchers had stumbled upon an atmospheric collapse so severe that it defied every existing model of atmospheric chemistry. What the team found was not just a slight thinning of the protective layer, but a massive, gaping hole torn straight through the sky. Covering an area of roughly 7.3 million square miles, this giant, invisible wound in the Earth's atmosphere hovered directly over the frozen continent. The protective barrier had degraded so rapidly that scientists measured the depletion in staggering double-digit percentages within a single season. This was the absolute worst-case scenario that chemists Sherwood Rowland and Mario Molina had warned about a decade earlier, now unfolding in real time. The invisible chlorofluorocarbons released from millions of everyday hairspray cans and kitchen refrigerators had drifted upward, gathering in the dark, freezing polar stratospheric clouds of the South Pole. There, trapped in a swirling polar vortex, the chlorine atoms began relentlessly eating away the very shield that kept humanity alive. To understand the sheer terror of this discovery, imagine standing inside your home while a deadly radioactive storm rages outside. Suddenly, the entire roof is ripped completely off, leaving you entirely exposed to the violent, unseen forces crashing down from above. The ozone layer acts exactly like that planetary roof, absorbing up to 99% of the high-frequency ultraviolet light emitted by the sun before it can reach the surface. That is exactly what was happening to our planet on a massive continental scale. The invisible chemical roof that blocked the deadliest ultraviolet rays of the sun had been violently torn open, and there was nothing left in the upper atmosphere to stop the danger from pouring in. Without ozone molecules to intercept this incoming solar energy, the raw radiation was free to bombard the ice and ocean below. Without that protective barrier, the fragile balance of life below was suddenly left completely defenseless against an unseen fire. Ultraviolet radiation does not just warm the skin, it aggressively penetrates cellular structures and shatters the fragile bonds of DNA. Every living organism beneath that expanding atmospheric void was now facing a relentless barrage of mutating energy that evolution had never prepared them to survive. The brutal biological consequences of a missing ozone shield are difficult to overstate. When raw, unfiltered radiation from the sun hits the ground, it acts like a silent, invisible poison that fundamentally disrupts the building blocks of life. Scientists quickly calculated that even a 1% drop in global ozone levels would trigger hundreds of thousands of new cases of aggressive skin cancer and irreversible cataracts worldwide. Essential agricultural crops like soybeans and wheat planted in the fields would suffer severe genetic damage and die in the dirt, leading to massive global starvation. Human skin exposed to this raw light would quickly erupt in deadly melanomas, while the microscopic phytoplankton that formed the absolute foundation of the ocean food chain would completely collapse. This mass die-off would trigger a slow, agonizing death for the marine ecosystems that feed billions of people. When the news of this massive hole finally broke in a May 1985 issue of the journal Nature, a sudden, visceral panic swept across the globe. People were absolutely terrified to learn that their daily conveniences were actively destroying the atmosphere. The media broadcasted alarming satellite images showing a deep purple void expanding over Antarctica, transforming a complex chemical theory into a highly visible, terrifying reality for the general public. Imagine waking up one morning, turning on the television, and hearing the evening news anchor calmly explain that the sky is literally tearing open. The abstract, heavily debated warnings of a few obscure atmospheric chemists had transformed overnight into a looming, existential nightmare for every man, woman, and child on Earth. There was no place to hide from a collapsing atmosphere, and no bunker deep enough to escape a dying biosphere. The invisible threat that began in quiet kitchens and bathrooms, leaking slowly from discarded refrigerators, aerosol deodorants, and foam packaging, had now grown into a terminal shadow hanging over the entire human race. The realization that decades of unchecked industrial progress had accidentally triggered a planetary self-destruct sequence forced society to confront the devastating power of human consumption. The damage was already done, and the chemicals were still rising. This sheer terror sparked a frantic, unprecedented scramble by world leaders and the United Nations Environment Program to stop the bleeding before it was too late. For the first time in environmental history, politicians realized they could not simply argue, delay, or ignore the problem away. The satellite data was undeniable, and the expanding purple void over the South Pole proved that the Earth was rapidly approaching a point of no return. The atmospheric crisis was moving too fast, and the massive hole in the sky was expanding with every passing Antarctic spring. Because chlorofluorocarbons can linger in the stratosphere for up to 100 years, leaders were trapped in a desperate rush against the clock. They knew with absolute certainty that if they failed to act immediately, the accumulated damage to the planet would soon become permanent, irreversible, and ultimately unsurvivable. This profound, unsettling reality created a diplomatic moment unlike any other in modern history. Mortal enemies, heavily armed and locked in the bitter, paranoid nuclear tensions of the late Cold War, suddenly realized they had no choice but to sit down at the exact same table. Representatives from the United States, the Soviet Union, and dozens of allied nations found themselves confronting a mutual enemy that could not be defeated with military force. The terrifying, undeniable threat of a collapsing sky forced these deeply hostile nations to look past their entrenched hatred and mutual suspicion. As they reviewed the horrifying projections of global crop failures and skyrocketing cancer rates, they understood a chilling, unifying truth. It simply did not matter who won the geopolitical war of ideologies if there was no longer a functional, livable planet left for the victor to conquer. Faced with the guarantee of mutual destruction raining down from the very air above them, the deeply divided world was finally forced to unite in an unprecedented global fight for survival. This desperate realization laid the critical groundwork for an international treaty that would demand immense economic sacrifices, proving that humanity could still pull itself back from the absolute brink of self-inflicted extinction. On September 16, 1987, diplomats and scientists from 24 nations gathered in Montreal to face an invisible atmospheric terror they had accidentally manufactured. Armed with terrifying satellite data from NASA showing a massive void over Antarctica, they sat down to write the Montreal Protocol, a desperate, unprecedented plan to save the global sky from total collapse. This international agreement was not a polite suggestion, but a strict, legally binding treaty designed to completely halt the production of the deadly gases eating our atmosphere. It operated as a global emergency brake, demanding that countries slash their chemical output in half within a decade, pulling civilization back from the brink at the very last possible second. What happened next remains one of the most stunning and consequential achievements in human diplomatic history. Over the following years, every single one of the 198 United Nations member states looked at the terrifying atmospheric evidence and formally agreed to ban the millions of tons of miracle chemicals that were running their modern industrial lives. These nations deliberately chose long-term survival over immediate economic convenience, legally mandating the shutdown of a multi-billion-dollar global enterprise dominated by chemical giants to protect a fragile stratospheric shield they could not even see. It was a remarkably rare moment of absolute unity, with bitter Cold War rivals cooperating seamlessly in an otherwise fractured geopolitical world. The sprawling chemical factories across North America, Europe, and Asia that once pumped out the wonder gas finally went quiet, marking the definitive end of a reckless industrial era. Millions of commercial aerosol cans, industrial solvents, and residential cooling units had to be completely redesigned virtually overnight to comply with the new international law. But pulling the emergency brake did not stop the runaway train immediately. Because these invisible synthetic chemicals boast an atmospheric lifespan of 50 to 100 years, the massive hole in the sky continued to tear open, reaching a record maximum of nearly 11 million square miles in 2006, almost 2 decades after the ban was signed. We had to wait, watching the upper atmosphere with bated breath through high-altitude weather balloons and orbital satellites, until the chemical damage finally peaked, and the Earth's ultraviolet shield began the painfully slow process of stitching itself back together. It proved that humanity could step back from the edge of total ruin, but full recovery would take until the 2060s. Yet, a dark and lingering question continues to haunt the atmospheric physicists and chemists who originally uncovered the terrifying truth. Through complex computer models known as the world-avoided simulations, researchers at the Goddard Space Flight Center calculated exactly what would have happened if we had waited just 10 more years to finally look up and take action. In that chilling alternate reality, the ozone hole would have spread far beyond the icy isolation of the poles, creeping steadily over crowded metropolitan cities and quiet rural towns. Blinding, deadly ultraviolet radiation would have rained down globally, pushing the UV index past 30 and turning the simple act of standing in the summer sun into a lethal gamble. We escaped that scorched earth scenario and prevented an estimated 2 million annual cases of skin cancer by the absolute narrowest of margins. The timely intervention also saved the global agricultural system from total collapse, as the unchecked radiation would have fundamentally destroyed the DNA of the foundational crops that feed the planet. But saving the high-altitude sky created an immediate, desperate logistical problem down on the ground. The global economy still desperately needed to keep its perishable food supply cold and its medical hospitals cool, and the reliable Freon machines that maintained the entire international cold chain were now strictly forbidden by international law. This hard deadline sparked a frantic, highly funded scramble in corporate laboratories everywhere to invent a brand new synthetic chemical from scratch. Chemical engineers needed a highly specific substance that possessed the exact thermodynamic properties to cool a refrigerator just as well, but absolutely would not eat the ozone layer on its way out into the atmosphere. The definitive answer they found was a new, heavily engineered class of chemicals called hydrofluorocarbons, or HFCs. By replacing the destructive chlorine atoms with hydrogen, these compounds broke down much faster in the lower atmosphere, and they were immediately hailed as the ultimate rescue mission, the new heroes of an industrial story that had almost ended in tragedy. A wave of immense relief washed over the global manufacturing sector as these new formulas quickly filled up our residential air conditioners, our supermarket display freezers, and our pressurized spray cans. The modern world could keep running its lucrative cold chain exactly as it had before, without tearing apart the delicate fabric of the sky. The massive commercial cooling engines hummed back to life across the globe, and the existential threat of a dying ozone layer rapidly faded from the public mind. The crisis vanished from newspaper front pages and political debates, swiftly replaced by a dangerous sense of technological triumph and widespread environmental complacency. The new replacement chemicals worked perfectly to protect the stratospheric ozone layer for one simple, verifiable reason. They did not contain the monster chlorine atom that had catalyzed all the previous destruction. But deep within their complex molecular makeup, these celebrated substitutes hid a dark, entirely unintended catch that no one was looking for. While these new molecules safely ignored the delicate ozone shield, they interacted with the sun's reflected heat in a completely different, deeply terrifying way. The strong carbon-fluorine bonds vibrated at the exact frequencies needed to trap thermal radiation, meaning we had solved one planetary crisis by blindly walking right into another catastrophic atmospheric trap. In a crushing twist of fate, climate scientists soon realized that these new, supposedly safe chemicals act like a heavy, invisible thermal blanket wrapped tightly around the Earth. Certain hydrofluorocarbons trap the sun's heat up to 1,430 times more powerfully than carbon dioxide, silently boiling the very planet they were engineered to save. The relief was short-lived as a devastating new reality came to light. Scientists measuring the atmosphere uncovered a crushing twist in the narrative of human survival. These new supposedly safe chemicals, while entirely harmless to the ozone layer, were acting like a heavy, invisible blanket wrapped tightly around the Earth. They were trapping the heat of the sun thousands of times more powerfully than carbon dioxide. The very solution that rescued our fragile atmospheric shield was quietly accelerating a completely different global catastrophe. The mechanics of this new disaster were terrifyingly simple and entirely hidden from public view. Every time an old air conditioner leaked or a damaged refrigerator was crushed at a junkyard, a plume of this new gas floated up into the sky. Once there, it did not destroy molecules, but instead absorbed the heat radiating from the ground, refusing to let it escape into the cold void of space. We had successfully plugged the hole in our sky, but in doing so, we had built a global greenhouse. The grim reality settled over the scientific community like a dark cloud. In our desperate rush to save the planet from deadly radiation, we had accidentally traded a bleeding sky for a boiling world. This bitter discovery forced an unprecedented shift in global policy, proving that isolated fixes are rarely enough. World leaders realized they could not simply ban one chemical and walk away, leading to a massive new legal framework to phase out the very replacements they had just championed. By the time the ink dried on new international treaties, the rules of industrial invention had changed forever. Governments legally bound themselves to a relentless cycle of monitoring, replacing, and regulating, knowing that no single chemical could ever be trusted completely again. On the ground, the human aftermath of this chemical gamble is felt deeply in the world's hottest regions. Families living in sweltering cities are caught in a cruel and punishing loop. They desperately need cheap air conditioning to survive the increasingly brutal summer days, yet the machines they rely on are silently making the world outside even hotter. It is a desperate paradox that hits the poorest communities the hardest. The very act of cooling a single room pushes the global temperature higher, leaving vulnerable people trapped in a worsening environment they have no power to escape. The broader aftershock of this crisis fundamentally shattered our blind faith in laboratory miracles. In October 2016, delegates from nearly 200 nations gathered in Kigali, Rwanda, to officially sign a pact against the replacement chemicals. This historic meeting marked the death of the 20th century belief that science could offer consequence-free solutions. The gathering in Rwanda proved that every chemical intervention in nature carries a hidden debt, and humanity was finally being forced to pay for a century of careless innovation. Yet even with new treaties in place, a massive and unresolved question haunts the environmental record. Millions of old cooling units are currently sitting in homes, businesses, and abandoned scrapyards, acting as ticking time bombs of invisible gas. No one knows exactly how to track or safely destroy this colossal stockpile before the metal rusts and the pipes crack. The sheer scale of the waste means that a catastrophic amount of warming gas could still leak into the atmosphere, completely untracked and unstoppable. The long-term consequence of our cooling addiction has spawned a shadowy and dangerous underworld. A highly lucrative black market now thrives globally, smuggling cheap, banned refrigerants across borders in disguised cylinders. Because the safe chemicals are expensive to produce, criminal networks have stepped in to supply the massive demand for cheap cooling. This illicit trade undermines decades of environmental progress, proving that legal bans alone cannot stop a desperate human need. The burden of this ongoing disaster falls heavily on the frontline workers tasked with cleaning up our industrial mess. In recycling centers around the world, technicians face the dangerous daily job of extracting these volatile gases from crushed machines. Armed with specialized vacuums and high-pressure tanks, they must capture the invisible poison before a single drop escapes into the air. It is a slow, hazardous, and deeply underfunded effort, placing the weight of global climate protection squarely on the shoulders of local scrap workers. The enduring legacy of our attempt to control the atmosphere is a profound and unsettling lesson in human limits. We believed we could outsmart nature with a simple spray can, only to realize that every action triggers a vast, unpredictable reaction. The story of our cooling chemicals is no longer just a tale of scientific triumph, but a haunting reminder of our deep vulnerability. We are left looking up at the sky, knowing that the invisible forces we unleashed will continue to shape the fate of our world for generations to come. Even as the ozone layer slowly stitches itself back together, a lingering shadow remains over the chemicals we used to replace the original threat. We flooded the atmosphere with new, alternative compounds to keep our refrigerators running and our homes cool, assuming they were safe because they left the ozone alone. But the ultimate fate of these replacement chemicals, as they break down and settle back into our soil and water, presents a haunting unknown. Scientists are now finding the fragmented remains of these new refrigerants accumulating in remote ice caps and deep ocean trenches. The unresolved question that keeps researchers awake is not whether these new invisible gases will change our world, but how long it will take for us to recognize their true cost. We solved the immediate crisis, but we cannot yet see the full bill coming due for the chemical substitutes we so hastily embraced. The most enduring legacy of this near catastrophe is not just the banning of a single chemical, but the creation of a permanent global surveillance system for the sky. The Montreal Protocol forced humanity, for the very first time, to establish a continuous, legally binding watch over the invisible gases surrounding our planet. Because of this treaty, international networks of specialized sensors now constantly sniff the air from mountaintops and weather balloons, hunting for rogue emissions. This intense monitoring transformed atmospheric chemistry from a quiet academic pursuit into a global security operation. When illegal factories in hidden corners of the world quietly resumed producing banned refrigerants a few years ago, this global alarm system caught the invisible plume drifting across the ocean. The treaty proved that a united world could not only write a law to protect the atmosphere, but actually enforce it by tracking a silent, odorless thief in the wind. Yet, treaties and censors cannot erase the damage already done to the communities living directly beneath the southern skies. In places like southern Australia, New Zealand, and the tip of Patagonia, the thinning of the ozone shield left a permanent, generational scar. Families in these regions still live with the highest rates of skin cancer in the world, a direct consequence of the ultraviolet radiation that poured through the chemical tear above them. For these communities, the sun transformed from a source of life into a daily hazard that dictates how children play and how workers dress. Local governments had to completely redesign schoolyards with heavy shade structures, and public health campaigns fundamentally altered the culture of outdoor life. The invisible chemicals released decades ago by distant factories ultimately forced millions of people to permanently change how they walk beneath their own sky. The chilling aftershock of the ozone crisis shattered the most dangerous assumption of the modern age, the belief that the Earth was simply too vast for human convenience to break. We learned, almost too late, that something as mundane as spraying a can of hairspray or cooling a kitchen could ripple upward and dismantle the very shield that makes life on Earth possible. It proved that human ingenuity is powerful enough to accidentally destroy the world, forever changing how we view the invisible consequences of our daily comforts. Somewhere over the frozen expanse of Antarctica, a lone weather balloon rises quietly into the dark, freezing stratosphere, carrying a small box of sensors. It drifts through the silent, invisible currents of the upper atmosphere, taking the pulse of a fragile, healing shield. It is a lonely, necessary vigil, a permanent reminder of how close we came to erasing our own sky and the fragile promise we made to never let it happen again.